Hello. Today we are going to solve one more problem from JEST 2020 and it's a part B. This is from part B, question number 15. And this is basically from optics, basically from polarization part. Then the question is given that you have a three polarizer. Okay, you have a three polarizer on 2 and 3. And on and 3 are basically cross polarizer. Cross means the path axis of this polarizer are perpendicular to each other. So if one is along x-axis, if I take this is your x-axis, another is along y-axis. And this middle polarizer is rotating with angular frequency omega. So I have to calculate that intensity of light crossing through this polarizer 3 as a function of time. That you have to calculate. Okay. Here you have given that incident ray on first polarizer, that is given, that is unpolarized light having intensity I naught. So unpolarized light incident on polarizer. On this polarizer is rotating with angular frequency omega, and you have to calculate that intensity of emerging ray as a function of time. Okay. Well, so let us assume that path axis of this polarizer initially at along y-axis or parallel to first polarizer. Now you see, when you are rotating this polarizer 2 with angular frequency theta, with angular frequency omega. So after time t, that angle between path axis of first polarizer and second polarizer, that will be, this angle will be theta equals to omega. Okay. So you have a second polarizer. I am assuming that is parallel to, path axis of second polarizer is parallel to first polarizer. Now this second polarizer is rotating with angular frequency omega, that is given. So after time t, the angle between the path axis of second polarizer and first polarizer, that will be theta, and that will be, depends upon time, that will be omega t. That we know from the concept of rotation of a body. Okay. Now, suppose you have an unpolarized light is incident on this. So according to Malus law, unpolarized light can have all possible direction of oscillation of electric field. And the direction of oscillation of electric field in unpolarized light, that is random. That can take all possible values from 0 to 2 pi. So obviously, if we apply Malus law, the intensity of ray crossing through this first polarizer, that will be I naught by 2. Okay. And same question, by the way, I forgot to mention this same question without changing any notation. Same question basically asked in JEST 2021 as well. The same question. Okay. So you have a I naught by 2, that is the intensity of the light that is crossing the first polarizer, and obviously the oscillation of electric field of this light will be parallel to the path axis of first polarizer, that will be along y-axis. Now you have the electric field that is incident on second polarizer. The angle between the path axis of polarizer and incident electric field, that will be theta. So now if I apply that Malus law, the intensity of light here, it will be how much? I'll use that notation I dash, that will be the intensity of incident light, that is I naught by 2, and the angle between, cosine square, the angle between path axis and electric field of incident light, that is theta, and that will be omega t. Now here you see, here you have again polarized light, but electric field is oscillating in this direction. I mean the angle between the electric field of oscillation with respect to y-axis, that will be theta. Or I can say the electric field is oscillating, that will be parallel to the path axis of second polarizer. Now I can see this is the cross polarizer. Angle between this and this is 90°, and the electric field is making angle with respect to y-axis, that is theta. So obviously the angle between electric field and the third polarizer, that will be 90 minus theta, because you have y-axis, x-axis, total angle is 90°. Electric field is making angle with respect to y-axis, that is theta. So obviously the electric field is making angle with respect to x-axis, that will be 90 minus theta. So your electric field is incident at an angle 90 minus theta. So if I apply again that Malus law, here the intensity I will be the intensity of light incident, that is I naught by 2 cosine square omega t, into, again you have to include that cosine square factor, but here that angle will be now 90 minus theta, that is omega t. So that will be, this is the intensity of light crossing through the third polarizer. Now I have to simplify that. You have a I, that is I naught by 2, and then you will have cosine square omega t, and cosine 90 minus theta, that is sine square omega t. Okay, so I naught by 2. Now if we multiply by 4, I can do that. I can multiply by 4 and I can divide by 4, and then you'll have cosine square omega t sine square omega t. Okay, that thing further I can write like you have 2 cosine omega t sine omega t ka square, that is nothing but 4 cosine square omega t sine square omega t. And this thing I can write 2 sine theta cosine theta, that is nothing but sine 2 theta. Okay, so you will have 2 into 4, that is 8 I naught by 8 into sine square omega, sorry, this is not omega t, that will be twice omega t, because here theta is omega t, so this will be sine 2 theta. Now again I'll use sine square theta is nothing but 1 minus cosine 2 theta by 2. So if I apply that, I'll get I naught by 2 into 8, that will be 16, and you will have 1 minus cosine, you have a 2 into 2 omega t, that will be 4 omega t. So this will be the answer, I naught by 16 on minus cosine 4 omega t. The same question asked in JEST 2021 as well. So this will be the intensity of ray polarized light here as a function of time. Okay. Okay. Thank you.